Don't need to. So good afternoon, everybody. Thank you very much for coming to our UKCRIC Global Outlook webinar today. We have the pleasure of having Dr. Alison Parker from Cranfield giving her presentation, which looks like it's going to be really very interesting. Like I mentioned before, if you can keep your cameras and microphones off unless otherwise asked kind of during the presentation, there will be opportunities to talk and discuss during the session. If you have any points of clarity and want to raise your hand kind of during the session, Alison says she's fine with that. Otherwise, pop your questions in the chat or save them up for the end. So I will hand over to Alison then. Thank you very much.
Yeah, great. Thanks, Jenny. So feel free to put any questions on in the chat, and I'm going to leave Jenny to sort of work out whether there's a sort of a question that's worth interrupting for and getting some clarification, because I want you all to stay with me the whole time. We kind of want to save questions to the end, but yeah, just keep sticking them in the chat or stick your hand up, and we'll deal with things as we go along. It's nice to be an interactive session, and with 15 of us, I think that's a really nice number to keep it quite interactive. So I'm going to talk about, I've been asked to talk on a global outlook on water and sanitation research, which I hope fits in with these series of webinars. So you'll have heard before, and you kind of heard this kind of stats about how many million people and billion people don't have access to water. But I want to kind of explore some of the stories behind these stats today. I'm not going to go over them in detail. I want to explore some of the stuff behind them to give you a kind of picture of what this actually means in reality. So I'm going to be using this framework a lot during this presentation. This is a project I worked on about a decade ago. But I still think it's a really, really good framework, and I think about this framework a lot. And it's specifically focusing on wash technologies, because a lot of the work I've done has been not on technology specifically, but on how technology interacts with the rest of the world. And really thinking across 6 different dimensions. So, like I said, the obvious one is to think about the technological dimension. Does it actually work? Does it actually work? Does it do what it says on the tin? Delivering clean water, delivering sanitation, treating water, getting water from A to B, providing good hygiene. Does it do that? But also thinking about the other dimensions. So about the economic dimensions, who is paying for it? Can they afford to pay for it? Is it expensive or too expensive, or is it cheap? Can it be reduced? Thinking about the social dimensions, do people like using the technology? Does it work well with their culture or not? Thinking about the environmental dimensions, which can be everything from kind of emissions and is it contributing to the climate crisis, or is it contributing to pollution, or is it removing pollution in the environment? Thinking about how it works in an organizational, institutional and legal framework in the setting where it is. Thinking about the skills and know-how used for that technology. So is it, do people know how to maintain it? What level of skills do different people at kind of a local, regional, national level need to have to make it work? So that's a framework that I've been thinking of. It's very easy to focus on the technological side of things, but I think all of these 6 dimensions are equally important when you're considering how to improve people's access to water and sanitation. So I'm going to take you through a couple of case studies today. The first is on sand dams, which is a technology that I've been working on for quite a few years now, and lots of different dimensions on that. And the second, I'm going to talk about container-based sanitation. So hopefully there's something in here for everybody. So starting off with sand dams. So a sand dam is a concrete wall. So the name's quite confusing, sand dam, but the wall is made of concrete and it traps sand behind it. So you can see the construction here. So the sand level on the right hand side of the picture is lower than on the left hand side because it's been trapped. So you're trapping sand, but you're also trapping water within that sand. So you're effectively building a mini aquifer. And these are installed on seasonal rivers, so where you have 1 or 2 rainy seasons in a year, and this allows water to be retained close to the communities for use in the dry season. And there's been thousands of these installed in Kenya and a few hundred elsewhere in the world. And yeah, something I've done quite a lot of research in, particularly in Kenya. So yeah, just to take a picture, to translate that diagram into an actual picture. So this is a sand dam in Kenya. So you can see here we're looking upstream. You can see the dam wall, and you can see the difference in level of sand behind the dam wall versus in front of it. So we looked at 3 dams in particular for our detailed study. This was back in 2017, and they were in Makueni County, which is in southeastern Kenya. And sand dams, there's sort of 4 different ways you can get water out of a sand dam. The principal way that would be in, all the kind of sand dam manuals and that type of thing would be the hand pump. So you can see the hand pump on the top left, and that's usually located just upstream of the dam. So if you can see, kind of looking over this picture, you can see the sand dam wall at the back. And there's the hand pump allowing people to access water from the sand dam. But people also get water out of the scoop hole, which you can see in the top right. So the scoop hole is literally just a hole that the communities dig into the sand to collect the water in the bottom of it. And there are also agricultural wells, which you can see in the bottom left. So these are large diameter wells that people are also using to take out water from. And then some of the dams have water ponded downstream. Now this is definitely not meant to happen. Your dam wall and any civil engineers in the group will definitely be thinking how maybe poorly constructed dam where the water is just literally leaking out of the bottom of it. But there it is ponding, and people are collecting water from this as well. So to focus on the technical question, do sand dams work? Are sand dams rainwater harvesting vessels? So they are something where the water is all collected and then abstracted steadily through the dry season, although they managed aquifer recharge. So actually the water is leaking out, having been retained, it's then leaking out of the bottom of the sand dam and increasing the water table in the surrounding aquifer. So that's been one of the kind of technical questions that I've been asking about sand dams. And we were aiming to construct a water balance. So a water balance has these different components to it. So we were able to measure evaporation, and I'll show you how we did that. We were able to measure abstraction, not in a particularly technical way, but looking at how many people are abstracting water, how many jerry cans are going out from the sand dam during the day. Looking at, we were able to estimate what the leakage to the dam wall was by looking at the groundwater gradient, and that left us with the leakage into banks. Anyone who's ever done any water balances in groundwater knows that they're really tricky, and you always have one component and you don't know that you have to work out by working out all the other ones and working out that it must be what's left. So how did we work out all of these things? So this was one of my postdocs, Ruth Quinn, measuring water levels in piezometers. So we installed a bunch of piezometers into the sand. So these are just literally tubes that you dig a big hole, put the tube in, fill the sand back in, and then that actually the water within the tube is the water level in the sand. And we didn't even use any kind of complex dip meter. We literally just use these thin bits of wood which we put into the piezometer, pulled out, and then you can see where the water level was, and then you could measure the wetted part of the wood to work out what the water level was, which is very, very simple but really quite effective. And that gave us these 3 maps or profiles of the water level in the dam. So you can see the dam walls are all situated on the right hand side of this image, and we had sort of about 6 piezometers located along the length of the dam, and we could measure how the water level within the sand fell over time. So you can see the different water levels in blue, red, green and purple as we progress through the season. So from something like the 24th of May, 17th of June, 8th of July, 26th of July. So you can see how the water level was dropping through the season, and you can see what the gradient was. So that allowed us to work out what the leakage rate through the dam wall was. We also looked at the evaporation. We're using lysimeters. So a lysimeter is basically another really high-tech piece of equipment. This was a rainwater harvesting barrel with its top cut off that we dug into the sand until it was level with the top of the sand, filled back in with sand, filled with water, and then as we had a piezometer in within that, and then we could see how much time, how that water in that piezometer lowered, the water in the barrel's lowering, and that gives us an idea of how much water is being lost through evaporation. So you can't go out the bottom of the barrel or the sides because they're solid plastic, so the only way it can go out is up the top through evaporation. And we also did a pumping test to work out what the hydraulic conductivity of the sand was, which helps us work out how much was going through the dam wall. So going back to our three dams, we had the three dams they had numbers 106, 167 and 211. And by doing that water balance, we could work out that, let's go for dam 211 first. So dam 211 on the right of this picture is losing water at the start of the dry season and in the middle of the dry season. It just keeps on losing water, recharging the aquifer below, but losing water from within the dam. Dam 167 was actually gaining water, so it was gaining water from the riverbanks, and that was flowing into the sand dam or into the trapped sand throughout the whole time that we were monitoring it. And dam 106, just to be the exception, was gaining water during the start of the dry season and losing water at the end of the dry season. So given that we picked these three dams really through convenience, they were just close to where we were staying, so we could get them and monitor them every day. We actually had three quite different types of typology of water balance in these three dams, so it's quite pleasing to sort of observe the kind of three different options. And then I had another student, Hannah Ritchie, who went back to some of the same dams and did something far more technical than our very basic hydrology measurements. She did a whole series of geophysical measurements, and she was then able to show, so what you can see here, this is the really leaky one, 211, and she's spent quite some time working out how to interpret the geophysics, but she concluded that what you can see on this diagram in the green colour is saturated saprolite and sap rock. So this is the aquifer material that's saturated, so it must be that the sand dam is leaking to saturate that much of the rock. So there's that paper is just out if you're into geophysics. Do go and have a look at that to see how, to see some of that basic hydrology confirmed by the geophysics. Okay, so that's really focusing on the technical dimension of sand dams, but I said I was going to focus on some of the other dimensions as well, and I want to think about what are people using the water for. So while Ruth was hanging around these sand dams for 3 months making all the hydrology measurements, she was actually, sort of serendipitously observing what people were doing with the sand and what they were doing with the water. And this is some photo of some brick making, which we hadn't anticipated at all, that people were using the water in the sand dam for such productive uses. So we then went and formalised that and created this table here. So it's a little bit of a complex table, but let me talk you through it. Across the top we have the 4 different types of water abstraction: hand pumps, scoop holes, downstream, and open well. And then we have the 3 dams down the side, dam 106, 167 and 211. And then we have the uses of the dam, the conductivity of the water from that particular source in millisiemens per centimetre, and the total thermotolerant coliforms, which is a proxy for microbiological quality. So that allowed us to give a kind of picture of all the different sources and the different water qualities and the different uses. So there's lots we can pull out here, but just to pull out one example. So looking at 167, it's quite kind of disappointing to see that the hand pump is used only for household cleaning, and the scoop hole is used for cleaning and drinking and cooking and personal hygiene, especially when you look at the TTC counts, which were at least 100 counts per 100 millilitres of water, which is very high, way in excess of any drinking water standard you find anywhere. So that was a bit disappointing. But when you look at the conductivity, you can see the conductivity of the water is 3.7 millisiemens per centimetre, which is way higher than in the any standard. That would be water that tasted salty. So suddenly you can see why people are not using the water from the hand pump for anything other than cleaning, because it tastes salty and they don't like using it. So lots of stories to pull out of here, but going to show that whatever you kind of technologically design, people will use water in a way that makes sense to them according to the quality and a whole bunch of other factors. But sticking with hand pumps, we also had the opportunity to measure the way the hand pumps were being used. So we put on these, they're called water point data transmitters, and it's basically a little accelerometer that you put on the hand pump handle. As the hand pump handle moves up and down, it measures how many times it's moved, and with some careful calibration you can work out what the amount of water, the volume of water that's been abstracted. And every hour that sensor sends an SMS to an SMS, which is then recorded, and you can translate that into a amount of water used per hour, and obviously you can total it per day, per month. So to give you an idea of the pattern of water use through the season. So another of Hannah's papers pulling out some of this data, and there's a huge amount of data in this paper if you want to go and have a look at it. But this is just one example. So you can see there's 2 different data sets on this graph. So we've got the precipitation is shown in the blue bars and the brown bars. So the blue is the wet season, the brown is the dry season, and then the abstraction is on the red line. So you can see through the 3 different years that we had this data for, you can see how much the abstraction increases during the dry season. So if people are rainwater harvesting in the wet season, when that water runs out, they are going to use the hand pumps on the sand dams to abstract water. We did this on 26 hand pumps, and in 21 some had some water abstracted in the last week of the long dry season. So that was really good to see that the water was lasting all the way through the long dry season. People were still using the hand pumps at the end of the long dry season. So you can really see the contribution that sand dams are making in those communities and giving them more water security, because they're using that water all the way through the dry season. Okay, so that's all I wanted to say on sand dams, except to, of course, thank all the people that contributed. I've really kind of claimed a lot of the glory here, but particularly wanted to thank Ruth Quinn, Justice Nyangoka, who has been a field assistant for pretty much all the work that we've done in Kenya. Hannah Ritchie, who I've also presented some of her work today. She's just finished her PhD, which is absolutely fantastic. And then the communities that hosted us, that coped with these random Mzungus wandering around, digging holes in their sand dam and asking funny questions, and really did make us feel welcome and facilitate the work. So big thanks to all of those. Okay, so I'm now going to stop talking about sand dams altogether and start talking about pit emptying, and a warning that my first and second picture in the next bit of the presentation are a bit gross. So you have been warned. So this is pit emptying, and this is the reality of it. So pit latrines are the sanitation that a huge number of people in the world use. But when they get full, they need to be emptied. And this is some pit emptying going on in Zambia. Another of my PhD students photographed. And what you can see here is the photo on the building on the right hand side of this photo is the latrine superstructure, and these guys have dug a hole next to it and then knocked through into the pit so that the sludge flows through, and then they're able to shovel that sludge out and put it into barrels. Now these guys are quite lucky. They are, as you can see, wearing masks and overalls and gloves and boots, and they've got some good equipment. But this is not the daily reality for lots of people emptying pits who don't have anywhere near as much PPE, and they're practically naked, just wearing a pair of shorts, going down pits to empty them, which obviously gives them a huge disease burden. Another picture from Lusaka. This is this is someone's backyard. You can see, although they've tried to do it quite nice and tidily, they have still spilt a lot of fecal sludge all over this person's backyard. And in case you want a justification, that's where people live. You can see the washing hanging up on the left hand side, and you can see the nice dresses. So this is someone's yard where their children will be playing, and there's fecal sludge everywhere. And this cannot be the best way to deal with human waste. So obviously sewers are one option, but they're quite hard to install in dense urban informal settings. So a new alternative has been coming up, which is called container-based sanitation. And this is container-based sanitation. So I've got an example of Sanergy in Kenya and Sanima in Peru, and CBS provided by the city of Cape Town in South Africa. And you can see here they're slightly different formats, but they are a toilet where waste is collected regularly. So not once every 2 years by a pit emptying team, but it goes into a container which can then be taken out. So it's probably easiest to see on the far right one. You can see the kind of seat is sitting on top of another container. You can take the seat off, take the container away, and that needs to be done sort of once, twice, 3 times a week in order to kind of keep the, because it gets full, so to keep the containers empty enough for people to use. And obviously we have squat versions of these, sitting versions of these, etc. So to sort of give you an idea of the chain of this, so you've got the containment, you've got the emptying, so probably by putting the containers on a hand cart, because these are really dense slums where there's not very wide roads, but you probably can get a hand cart. Then the hand carts are transferred onto a truck, and they are taken away for treatment, and then for final reuse and disposal. So going back to my 6 dimensions, I want you guys to have a think about how CBS works in these dimensions. So have a think, and maybe you can either stick your hand up or you can put some answers in the chat. I'd be interested to know what you think, and I can talk you through some of my experiences, but I'd be interested to know what you think first. So please do stick your hand up, put some answers in the chat, and I will be glad to hear from you. I'll give you a couple of minutes to have a think. Yeah, Duncan, go for it.
Thanks. I work for Marwell Wildlife in Hampshire. We're a conservation charity and zoo operator. But we've got one of our sort of main overseas programs is in northern Kenya.
Right.
And I think I saw in the sort of introduction and the write-up to this event that you'd done some of the sand dams in the northern part of Kenya, which is obviously quite a dry part of the world.
Yeah.
And water availability for the locals and their livestock, but in our case for the wild animals, is quite an issue. The seasonal rains do or don't come depending on the different years for different things. I was just wondering, does that sort of thing work in that region? And I guess a supplemental question, we've seen projects, I think it's Dig It, and people who dig sort of semicircular bunds to try and capture surface flow for regreening. Do you get a lot of regrowth along the rivers where you've done these sand dams?
Good. Two really good questions. The first, do sand dams work in northern Kenya? There've been far more in southeastern Kenya than anywhere else. I'm about to start a project looking at them in Isolo County. I don't know if that's as northern as you would like. So there are some there. I don't have a full picture of where they all are exactly in every county in Kenya. So it really depends on where you've got the rocky banks and the because you need the rocks to put the dams into, because otherwise the water just kind of goes around the edges. As any good civil engineer will tell you. And then in terms of the regreening, yes, we've done a little bit of work on that, but I'd like to do more. I'm trying to get some funding for a PhD to look at that maybe next year. So I would like to look at that, because there's quite a lot of remote sensing data you could use to answer that question, as well as sort of sitting there and counting trees. I'm not an ecologist, so I assume that they might do something more advanced than counting trees. But yeah, I'd really like to work on that, but I haven't got a really solid answer. But anecdotally, I think you must be right. Yeah.
So I mean, if you because obviously up in the north, the settlements are much more sparse. So if your primary motivation was regreening rather than providing sanitation water, I want to do both, obviously. Could you bung a dam in every 100 meters down a river and create a sort of
every 100 meters is probably a bit too frequent, but they do have cascades of sand dams for sure. So you could, and they because each sand dam traps such a tiny proportion of the water in that river. It doesn't. You can have a cascade of them, and the one at the bottom, and still anyone who's downstream of that is still going to get plenty of water, because it's really catastrophic floods.
Yeah. Okay, great. Well, perhaps I shall catch up with you afterwards or another
definitely.
time.
Thanks, Duncan. So we were the question that was set was all about thinking I was going to take questions on the sand dams at the end, but Duncan's question was so good I just had to take it straight away. But any other comments on, do you think CBS works across the 6 dimensions? So does container-based sanitation work? Is it good economically, socially, environmentally, organisationally, and with skills and know-how as well as technology? Anyone got any thoughts about what may or may not work?
There are 3 or 4 responses in the chat. Do you want me to read them, or can you access it?
No, they didn't ping up and tell me, but let me have a look at those. Lizzie's asking, in social context, is acceptance a barrier? Natural instinct is to have waste away from you, but in a CBS it is close by. Yeah, exactly. That's when we flush a toilet, the waste goes. I mean, most of us don't think about it. It just goes somewhere else that isn't our house, but you're storing it in your house. Obviously, it's in a pit latrine. You're storing it in your house for several years, and in this context, you're only storing it for a short amount of time. But yeah, Lizzie, that's a really good thought. And how do people like kind of storing that waste, even for a few days? Matthew, in terms of skills and know-how, I assume CBS is easier to manage and operate compared to sewers and other on-site options like urine diversion dry toilets. So CBS, the emptying is very simple. You just literally take a container away. It's not very technical at all, but you have to keep doing it again and again and again and again. You can't, it's definitely not a kind of fit and forget kind of technology, quite the opposite. So skills, it's not a very skillful job, but the skill is potentially in the organization of that system and making sure the collectors are going every month, or every week, or at the regularity. He had quite a lot of complaints about the collector was meant to come at this particular time and he was late, and that was inconvenient. So really the kind of management of that system is quite tricky, and that's probably where the skills and know-how come in. Loads of questions, fantastic. Lizzie, is there acceptance of using treated waste on land? Is there a link between current and former open defecation practices and acceptance? That's another really good question, Lizzie. So we spend a long time telling people not to open defecate, and then telling people also to reapply waste onto land, which they're kind of effectively the same thing, right? So that's a really, really good question. And I've got a little bit more on circular economy and putting waste on land coming up. So I'm going to come back to that one. Debbie says, environmentally, CBS prevents pollution of important things like water sources, farmlands, and protecting health of locals. Absolutely. So I think environmentally, it is preventing pollution. So it gets a big tick in that box. Claire, potential for job creation through emptying. Yep, absolutely, emptying transport and treatment processes. So it is quite a labour heavy process, CBS. So it's creating jobs, better environmental protection, contained and more managed waste disposal and treatment does not require additional water supply to remove waste. Yep, so the same kind of points that Debbie was making about protecting the environment, and and it's doesn't require water. Some of them do. So the one in South Africa use about 1 litre of water per flush, but lots of them don't. So depending on the exact CBS technology, it uses far less water than a conventional method. Brilliant. Thank you for those. I'm going to move on to talk about some of those issues, I think. But let me first move on, in fact, to the issue that Lizzie raised on the circular economy. So I had a student, Berta Moya, a few years ago looking at two different CBS organisations. One was Soil in Haiti, the other was Sanergy in Kenya, and how Sanergy, I should kind of say, have now changed their process somewhat and are doing black soldier fly larvae, but which is a fascinating process. But this is composting. So they're collecting the waste, potentially combining it with some agricultural byproducts and making compost. These are two examples of compost being made from waste collected from a container-based sanitation. And everyone's getting quite excited about this, but I had a few reservations. So myself and a colleague, Adrian Mallory, scratched our heads and did a review of how much money people are actually getting from fecal sludge reuse. So what Adrian did was he found all the studies he could about how much money people were getting from fecal sludge products, and he assigned them to a series score of 0, 1, 2, or 3. So if it had a score of 0, someone was actually doing it, and this was recording the actual money they were actually making. And if someone had a score of 3, it was very much a feasibility study, that they hadn't actually done it, but that's what they thought they could do. And then there was 1 and 2 in the middle. And you can see here there is a score, there is a kind of trend. So some of the feasibility stores were very optimistic, getting $30 or $55 per person per year from their fecal sludge. But we find quite a lot of these seem to be making some maybe quite unrealistic assumptions. And what people were actually managing was down here in the bottom left corner, maybe 5 or 6 or quite a lot less than that dollars per person per year was the financial value of fecal sludge, and that doesn't include the cost that it's got to make to that. That's just the money you get from selling it. So any costs that you've got for the collection, the treatment are not subtracted here. So I think what we can conclude from here is that the sludge is not terribly valuable in terms of making a product, but obviously it does need to be dealt with. So don't take away from this that I don't think the circular economy is worthwhile, and I don't think it's worth treating weight. It's definitely still worth treating weight, but it's not going to be a driver for sludge reuse, or not going to be a driver for providing toilets. So thinking about some of the social aspects, this was a survey that we did in the 3 countries I initially showed you the CBS in. So this one is the example, as you can see from the Spanish. This is the a Spanish survey, but we did it similarly in, so for Peru, we did it similarly in Kenya and South Africa. And it was on smartphones. So people got paid a micro payment for completing a survey, and they got a survey every day about different aspects of their sanitation and all sorts of topics. Let me show you on the next slide. So we had 100 respondents in each of our 3 countries. About 50 of them were CBS users and about 50 were non-users, and we were trying to have an equal split of male and female. And they got asked questions weekly and quarterly on a whole bunch of topics. So we asked them about their well-being, we asked them about shocks, we asked them about what toilets they were using, what sanitation they were using, a whole bunch of stuff. So some example questions were, how many toilets did your people in your household use this week? Were there any problems with the toilet this week, etc., etc. We have a huge range of those toilets. A huge range of those questions based on the kind of different toilets that people were using. And some examples of the data coming from this were what problems do people have with their toilets. The thing to focus here on is the green bars. So you can see that the green bars tend to make up, especially in Peru and South Africa, happily people are not having problems with their toilet, but they're definitely having, the CBS users are having, more of them are reporting no problems with their toilets than the non-CBS users. So the CBS users are having a more problem-free experience, an easier experience. And then obviously you can look at the minor in the yellow, moderate, orange and red, serious, and you can see the kind of distribution of problems that people are having. But we did test this, and it was true that the CBS users had a lower severity of problems using a chi-square test. So that was quite pleasing to the organisations providing CBS. To look at what the problems were, we were looking at, was there a problem with the collection? Was the replacement cartridge clean? Was a clean cartridge available? Was the toilet sufficiently cleaned? This paper is actually, you've seen probably in some of the previous slides, I've got the paper reference. This one's still under review, so I can probably send you a copy if you're interested. But hopefully it will progress smoothly through the review system. So this is just some examples of the kind of questions and the data that we have. But we have a huge amount of data. In this project, we had quite a lot of time for data analysis, but we prioritised it for some of the advocacy work that some of the organisations wanted to do. So there's quite a lot of research questions that we just didn't manage to get the analysis done. So if you're a student who's looking for a project, or someone who's looking for some more data on container-based sanitation, then please do have a look at our data. It's all there, freely available to use. I'm happy to have a chat with you. But there's lots of data that hasn't been analysed yet. Have a look on that, and that's the website where it is. So also thinking about intersectionality. Maybe some of you have come across this concept, but I can explain it anyway. So intersectionality is not thinking about people having maybe one or two protected characteristics, but everyone has a different set of characteristics that make them vulnerable, and in this context affect how they're accessing water and sanitation services. So it might be that that people's race or sexuality or gender or class or things that aren't on this diagram, poverty, things like that, all intersect affect how people access water and sanitation. So we were interested in looking at this through the through using a photo voice method. So photo voice is a participatory method where you provide cameras to people, to your kind of participants, and you train them in how to use the cameras. You send them away with their cameras, get them to take pictures, and then they, for us, we were telling them to take pictures about, that showed their sanitation experiences. You get them to pick the best 5 pictures from the ones that they've taken, and then you use those 5 photos as prompts. So they make captions for the photo, and then you use those as prompts to get them to talk about what their lived experience of sanitation is. So to give you examples from a couple of countries, so in South Africa, people did like the toilet. So the top right photo shows how difficult it can be to access the toilet. So I think the kind of green and white sort of structures at the far side of this picture are toilets. So people who don't have CBS have to try and access that, which, you can see the flooding here, not very pleasant to wade through water to get to the toilet. But people did find it challenging to find somewhere to put the toilet. So you have to find somewhere in your own house to put the toilet and adapt it. Potentially, if you are disabled, you have to think about how you're going to adapt that toilet for your particular needs, and you don't get any support for that. You just get provided the toilet by the council, but there isn't any additional support to think about where it's going or how you are going to fit it into your space and make it work for your particular needs. But people did really appreciate having a toilet in their home rather than having to walk a long way to access the toilet. So a mixed experience there. In Peru, people found, particularly people with disabilities, found that the toilet was quite challenging. The waste was quite challenging, had a lot of steps. So this Plona Alta, where the settlement is, was is everything okay, Jenny?
Yep, everything's fine.
Okay, cool. So I saw you were unmuted and I was suddenly having a panic that you were trying to get my attention. It's so hard when you can't see any faces to know what's going on. Great. Okay, well, just the last few slides here. People were walking up, having to walk upstairs to carry their waste, some quite steep stairs in this very hilly settlement. And that was quite challenging for people who were had mobility issues, quite challenging to work out where to put the toilets. Again, the middle photo shows you kind of quite how steep it was. And on the left-hand side, you can see the drainage. So people who had pit latrines were using the pit latrines to dispose of grey water, so washing water and stuff in their homes. You can't use the CBS for that. So the people with the CBS were kind of just throwing their grey water onto the street, and then their neighbours were getting annoyed because the grey water was flowing past their front doors. So those are some interesting perspectives from Peru. So the conclusion from the photo voice study was that container-based sanitation, particularly at the household level, can improve the sanitation experiences in formal settlement residents. But that's contingent on the availability of resources to afford and adapt the sanitation choice to the local physical, sociocultural, religious context and the user's individual needs. So largely a positive picture, but with some caveats. The other great advantage of the photo voice is that you get with a bunch of pictures, and all 3 countries were able to use these for advocacy purposes. And so this is kind of going into that institutional dimension and thinking about who is providing the sanitation and who is paying for it. So the left-hand picture is an event at the University of the Western Cape that our partners there hosted, where they displayed some of the photos and invited some of the participants, the CBS users who were participants in the survey and in the photo voice, to come and speak and really share their experiences in a university setting, which is not somewhere where they'd normally get the opportunity to have their voice heard. And this has gone on. This is kind of multiplying up now, and they're about to run a tour for the mayor to one of the informal settlements as a result of this project. So the mayor has never been to an informal settlement before, despite being, having a lot of informal settlements within Cape Town that, are within his remit. So this is a really kind of fantastic opportunity that's arisen as a result of this project. The bottom right is a display that the Catholic University of Peru put on in Lima, and the top right is in Nairobi, where they were able to gather together the CBS company, the water utility, and a lot of the CBS users together to so the CBS users could have their voices heard. So some fantastic advocacy going on as a result of this project. The last thing I really want to say is it's not all kind of happiness and rainbows. This is a photo from Cape Town, where people really didn't like having the CBS. They considered it to be completely inferior to the to having a flush toilet. For some of the reasons that Lucy was talking about, having storing waste in your house. So they took their protest in quite a direct way and took some of the containers and threw the waste over various officials' cars. As an act of protest to say, no, we want better sanitation. Just because we're black and we live in informal settlements doesn't mean that we're not, we shouldn't get as good a sanitation as the white people who live in the big posh houses. So there's quite a lot of interesting dimensions to think about there, and all really brilliantly described in the paper that I've referenced below. So again, I want to say this was definitely not my work alone. There was a huge team, and this is the team gathered at our project meeting in Kenya, and all the different organisations represented there. So brilliant thanks to all of those people whose work I've hopefully talked about, given a good enough explanation of today. So that is all I wanted to share. I think I should have 10 minutes left for questions. So I'd be really happy to get any questions. I guess I could go through, looks like there's one more question in the chat, but I'm also happy to take any questions by people sticking their hands up. So I'll give you a chance to think about that, and I'm going to read Duncan's questions. This is packaged water treatment plant that exists, treats material in a container and emit clean water. What's the advantage of CBS compared to these? Guessing it's the availability of water treatment. Assuming it means a packaged wastewater treatment plant that treats material in a container. I mean, yeah, packaged treatment plants are great, but you need space for them to work. And one of the challenges in the informal settlements is the lack of space. Even to run a transfer station where you kind of take the containers and transfer them onto the trucks. Even finding space for that has been really challenging. A packaged treatment plant, the footprint to scale it up for a whole informal settlement is just massive. So, that's why things like CBS have been developed. Right, that's given the rest of you any chance to ask any questions. So I've got the chat up now, so I can now see it. And any other questions, people want to raise their hands or type anything in the chat?
Do you want to unshare your screen and then we can see people?
I've managed to stop sharing. Yeah.
Right.
I can see everyone's little initials.
Fabulous. Well, thanks very much. That's really, really interesting. To kind of see all the different work that's kind of going on out there. That's, really quite different to how we kind of live in this country. But that's a kind of, that those are the solutions that they have there. And that challenging photo at the end, where of the protest, kind of really does show that you can't just impose one solution on people without having heard the voices and taken those into account. And I think that kind of works for a lot of research, whether it's kind of the work that you're doing here and kind of other solutions that kind of seem, things are imposed upon communities that haven't, been thought about from a particular perspective. So yeah, that's interesting. And
I would think that would go for kind of all the webinars you have in this series. You can't just go and impose a solution. That's incredibly colonial perspective. There's a lot of you need solutions that people want, that come from people, that come from the people who are only in the situation of this very resource poor situation because of colonialism in the first place. So let's redo it.
Yeah. Matthew's put a question in the chat.
Oh yeah, great. Regarding hand pumps water abstraction, do you have any idea the water was more salty compared to the other abstraction methods? A little bit. I haven't managed to prove this idea yet, but the hand pumps tend to be constructed sort of in the rock at the side of the dam rather than in the sand, and I think that rock in itself is salty. There's an anecdote of someone drinking the water of women eating that rock when they're pregnant to give them kind of extra nutrients. So I think that's quite a challenge. I think that's quite a challenge because it's making the water salty. So thinking all of the thinking about everything all together is quite challenging. Seeing the next question from Debbie. I'm from Kenya, and seeing all these projects is really interesting. Coming from a place where we don't have these problems is eye-opening. Random Wazugus is funny. Claire, thank you for the presentation. Could the sand dams impact potential for flooding when the rains occur in the rainy season? I don't think as a flood mitigation strategy they're great. They just don't trap very much water. So it's great because they don't, you can put loads of them in a row and they all still get water and there'll still be water for downstream. It's not like a kind of upstream resource capture kind of scenario. But I don't think they're great for that reason. They're not great for flood mitigation. These are such, the monsoon rains in Kenya are such huge events that one little sand dam isn't going to have much of an impact. Any last questions?
I was just going to say about is that's where kind of thinking systematically about kind of the whole system, kind of like what happens when there's too much rain, what happens when there's not enough, how the effect on downstream is if you put something upstream, and kind of considering holistically the whole situation.
Systems thinking is definitely a buzzword in the WASH sector at the moment, so I'm almost reluctant to jump on the systems thinking bandwagon, but you're right, you've got to you can't look at anything in isolation, you've got to look at the bigger picture. I think that's kind of what your kind of framework shows, that there are so many things that you have to consider when making any decision about all these sorts of things, whether it's economic or social or environmental or et cetera, and actually considering people holistically and communities kind of, and how they all kind of work and how they interact with each other, I think is really fascinating part. And I think what we learned in our kind of webinar last is that idea of kind of justice and working with people and kind of creating kind of solutions that are people focused rather than kind of like technology focused. Just because we can do something doesn't necessarily mean it's the right thing to do. Exactly.
And I think kind of actually as an engineer having that mindset to go, yes, I've got a widget that I want to use, but is this really the appropriate place to be using it? And is there some, are there other solutions that are better or more appropriate, or can we co-create with the people who have the problems? And that, I think, is something that kind of can go across many sectors, and not
exactly.
So that's great. Anyone else have any last questions or queries for Alison whilst we have her here? That might be a no. So thank you very much, Alison.
Well, thank you for all your engagement. It's been great to hear all your ideas, and yeah. And if anyone has any questions, I'm sure Alison will be very happy to answer them online. You'll be able to find her at the Cranfield email address for a little while longer, at least. So thank you very much, everybody, for attending. Keep an eye out on the UKCRIC website and in your inboxes for any future events that we have similar to this. This is, I think, our last Global Outlook for the time being, but we will probably pick up the theme again sometime next year. So thank you very much, Alison, and for everybody else. Thank you, Jenny, for the invite, and to everyone for attending.
You're very welcome, very welcome. And I wish you all a Merry Christmas, as it happens to be December, and we can do that. So have a good end of the year, and a nice break. And yes, good luck for everything in the future.
Okay, thanks then.
Thanks then. Bye-bye.
Bye.